Hi, linear algebra students. So this is the last example of section 1.1, linear system. It's an exercise. You should try it by yourself first. So if you didn't do it yet, you should certainly close that video, have a try at solving this problem yourself, and then if you are not able, follow the steps in the video in order to gain more confidence for the next time. Okay. So we are about to solve this linear system. Um, so the first thing we're going to do is to put it in a matrix notation. So as we covered in this section. And what we have to do is all the numbers that are here, so 5, -2, and don't forget if there's not a coefficient in front, that coefficient is actually 1. So we start by writing down this matrix with 5, -2, and 1. So that is the first column. Remember, it represents the variable x1. Okay? So the columns represent the variables and the rows represent the operations. The equations, I mean. Okay, now the second column. Notice that we don't have any x2 over here. This means that this entry of the matrix will be 0. So it's like saying 5x1 plus 0x2. Okay, then we have 3 and 2. So in other words, these entries over here. So over here we have like 0. And then finally we have 1, 4. So 1, 4. And don't forget the sign here, be careful, -1, right? So this represents x3. Now remember that this line represents equal, right? So we are putting the constants here. So in other words, the 13, the 8, and the -1 go on the other side of that line. Okay. And now what we want to do is to put it into a diagonal form. Okay. For those of you who if we actually covered 1.2, what I actually mean is the reduced row echelon form of the matrix. Okay, but that is in section 1.2. So for now, just what we want is ones in the diagonal and zeros elsewhere. Okay, and remember the way to achieve that, you have to create in every column. Your aim is to create a pivot and turn the other entries into zeros. And we're doing the entries below first. And once we're finished that, we will do the ones at the top. Okay, so we would like this to be a 1. It's a 5, so no good. So an easy thing to perform in order to have a 1 here is to interchange row 1 and row 3. So let's do it. Okay, so we interchange row 1 and row 3. I'm going to shorten my arrow a little bit. There you go. Okay, what I'm going to do now is every row that doesn't change, I'm going to leave it in black. And the rows that are changing, I'm going to put them in blue so that you follow along. So here we have 1, 2, -1, -1. And the first row becomes the third row. So 5, 0, 1, and 13. Okay. Now here, what we want to do is to create 2 zeros in these positions. Now that we have a 1, we want to use it to create the 2 zeros. And both operations that we will perform only affect their own row. So for that reason, we're going to perform them all at once. So to create a 0 here, what we need to do is to add twice row 1 to row 2. So in other words, the row number 2 becomes, row number 2 plus 2 times row number 1 becomes the new row 2. That's how you should read this line. Okay, and in the same way, row 3, what we need to do is to subtract 5 times the row 1. So in other words, row 3 minus 5 row 1 becomes the new row 3. Okay, I don't have enough space to put the new matrix here, so I'm going to put it underneath. Okay, so now it's the row 1 that doesn't change. So 1, 2, negative 1, negative 1. And then it's easy to see that we have zeros here. It's nice to check it just to make sure that you're doing the right operation. And then for the rest of the entries, you have to do the math. So 3 plus 2 times 2. So that's 3 plus 4, 7. And 4 plus 2 times negative 1. So that's becoming 2. And then finally, 8 plus 2 times negative 1 becomes 6. Now, 5 minus 5 is obviously 0. That's the point of this operation. And 0 minus 5 times 2, so we have a negative 10. And we have here 1 plus 5, so that's going to become 6. And finally, 13 plus 5, so 18. Okay, I'm going to move near the picture of my wife and son just to show you. Okay, now this column has a pivot, or actually what I should say is that this row has a pivot, because the next step is, remember, to hide the row with the pivot, and then you work only with the 2 rows beneath. Okay, so, and then you would want a pivot over here. Okay? Okay, not an easy task, because 7 and 10 are not really numbers that are nice to work with. Okay. The first thing we're going to do is take advantage of the fact that this row has a common factor. So we're going to scale row 3 down by 2. So row 3 times 1/2 becomes the new row 3. So as a result, we have 1, 2, negative 1. Okay. And then negative 1. And okay, so here, 0, 7, 2, 6. And finally here, the row that changes, 0, 5, 3, and 9. Okay, now we're not in a good position, because 7 and 5 are prime numbers, and we cannot get a 1 by adding or by subtracting some multiple of a row to another one, or at least it would be very complicated. So one of your options here, remember, is to scale the row up by 7 and then subtracting 5 times the second row. Okay, so let's perform the operation that will scale up the third row by 7 first. So in other words, we're multiplying row 3 by 7. Okay, so for those of you that saw what was coming, you can actually multiply it right away by 7 over 2. Okay, so you can do that kind of operation at once, but just be careful that the more you do in your head, the more likely you are to do a calculation mistake. Okay, so here, 1, 2, negative 1, negative 1. Okay, now 0, 7, 2, 6. So in other words, that 7 will be our pivot, because look, the third row will have very high numbers. 5 times 7 is 45, okay? Don't be scared. Wait, 5 times 7 is 35, never mind. Okay, and then 7 times 3, 21. And finally, 7 times 9, that's going to be 63. Okay, good. Okay, so the numbers are high, but they're going to go down. Because now, these two numbers are multiples of 7. So knowing that 35 is 5 times 7, what we're going to do is we're going to subtract 5 times the second row. So I'm going to write the row operation over here. So row 3 minus 5 times row 2 becomes the new row 3. Okay, so, okay, we have 1, 2, -1, -1, 0, 7, 2, and 6. And then here, what's changing? We have 35 minus 35, so 0, that's good. And then be careful here. This is the tough operations. 21 minus 10 is 11. And then we have 63 minus 30. So that's going to be 33. Okay, so first of all, we know here that we have a single solution because then we can easily solve this. Back substitute, solve for y, solve for x2. I mean, back substitute, solve for x1. Okay, we're very lucky because these two numbers are multiples. Things could get crazy if they were not. But let's use this to our advantage. We're gonna do row 3. We're gonna divide it by 11. Okay. So 1, 2, -1, -1, 0, 7, 2, 6. And then we have here 0, 0, 1, 3. All right. This is the end of the forward phase because as you can, well, actually the forward phase ended here, okay, where we had our 3 pivots. This is actually the beginning of the backward phase. The scaling down in order to get a 1 was in order to get a pivot to cancel these two. Okay, so now this is our aim. We want to put zeros in these positions. So we're going to do the row operations here. So what we need to do is row 1, we need to add row 3 to it. That's going to become our new row 1. And row 2, we have to subtract twice of row 3. And that will become the new row 2. So now notice that it's the third row that doesn't change. And the second and first row that are changing. So here, now the calculations are easy to perform because we have zeros here. So here we go, 1, 2. And -1 plus 1 is 0. And -1 plus 3 is 2. Here we have 7. Oh, well, actually 0, 7. That is quite simple because we're just adding 0. And 2 minus 2, 0. That's good. And here we have 6 minus 2 times the 3 over here. So 6 minus 6, 0. Perfect. All right. So now remember, we created a pivot here. So what we want to do now is to hide this and work only, actually I'm going to go on the other side, there you go, you hide this, and you want to work only with the first 2 rows in order to create a pivot over here. Well, actually these are already your pivots, but you want to make the zeros above these numbers. You want to make the numbers above these pivots to be zeros. That's what you want. So, again, look at how lucky we are. This constant ends up being 0, which makes the whole row a multiple of 7. Take that to your advantage. Scale it down by 7. So we have row 2 times 1 over 7. That is becoming the new row 2. So 1, 2, 0, 2. And then the second row becomes 0, 1, 0, 0. And finally, the third row, 0, 0, 1, 3. Okay. The last thing we want to do is, now that we have a 1 here, we have the perfect pivot. We want to make this 2 into a 0. So we're going to change the first row. And what we're going to do to it is to subtract twice the second row. And from there, we have our final matrix. Okay. Then we have 1, 2 minus 2, 0, but just to make sure, right? 0 minus 2 times 0. And then we have 2 minus 0, so that's 2. This number doesn't change, but it's only by chance because it turns out that this number is 0. Otherwise, you need to perform the calculation. All right. Now, this is our diagonal matrix. Let's use a new color. Let's use orange. So look, we have 1s here, and then everything else are zeros, both on the top and on the bottom. And these, remember actually that this column is representing x1, this column is representing x2, and this column is representing x3. So in other words, the solution to this system is, so in other words, x1 plus 0 x2 plus 0 x3 is equal to 2, okay? 0 x1 plus x2 plus 0 x3 is equal to 0. And finally, 0 x1 plus 0 x2 plus x3 is equal to 3. Okay. Okay, so things are a little bit... Oh, actually here, I'm going to write the solution set at the very bottom, and that will be it. Okay, so here, solution set. Okay, so you put the curly brackets like this, and you put your solution as being a point, right? Or a list, if you prefer. So 2 will be the first coordinate, 0 second coordinate, and 3 the third coordinate. Okay, so final answer. So this is if you are asked the solution. Okay, and this is if you are asked the solution set. All right, this is it. I hope this was helpful. So see you in the next video or in next class, basically.